Okay, in our previous session, we discussed up to question number 17 and now question number 18. So let's see what they are asking in this question. They are saying which statement of the element in period 3 and the group 13. Group 13 is basically, if you look at this, the period 3 members, they are sodium, then comes magnesium, and then group 13 member that is aluminium hmm, of the periodic table is correct. So they are saying group 13 member about aluminium, they are asking. It has highest melting point of the elements in its period. Okay. So when we move from left to right, these are actually the metals, and then the member of group 14, silicon, which exists as a giant structure, giant covalent structure. So having strong covalent bonds. So due to this, we know that this member of group 14 have higher melting. And after that, we know that elements like phosphorus and sulfur and chlorine, they exist as small molecules. Can you please hold for a second?
Sure.
Okay, so what I was saying, when we move from left to right, no doubt their melting points, they are saying melting points, they increases, but this member of group 14, silicon, has strong covalent bonds, so it has higher melting point as compared to this aluminium. So it means this option A is incorrect about this aluminium. What next they are saying? It has exactly one electron in its shell with principal quantum number 3. Okay, when we look at the configuration of aluminium, so we know that neon, 10 electrons, and after that there is 3s2 and 3p1. So this is the outermost shell, and it has 3 electrons in it. So they are saying 1 electron in its principal quantum number 3 means third shell. So that is also incorrect. Now let's see option C. It forms an oxide that reacts with aqueous sodium hydroxide. So we know that aluminium oxide, that is amphoteric in nature. So it can react with acids and with alkalis and giving us salt and water. So here they are saying reacts with sodium hydroxide and alkali. So it will behave as an acid. So remember this reaction, when it reacts with an alkali, aqueous, it gives us sodium aluminate, NaAlOH whole 4. So yes, it is true. What about D? It forms a chloride that dissolves in water to give a neutral solution. Okay, aluminium chloride. And when it reacts with water, so actually it gives HCl, right? And which is a strong acid. So that gives strongly acidic solution. Clear? So that's why
Yeah.
option D is incorrect. So the correct option is C. Okay, now let's move on to the next question. They are saying a student reacts 0.1 mole of each of sodium, magnesium, and phosphorus atoms separately with an excess of oxygen. So they are saying which rows are correct, 1, 2, and 3. So we have to check all of them. So first of all, let's see sodium. When it reacts with excess of oxygen, it means combustion, and it gives us sodium oxide. And now the ratio between, let's balance this equation. So it will be 2Na, and we can write it like this, half O2, because it is an excess. So the ratio between sodium metal and its oxide, that is 1:2. And they are saying zero point 0.1 mole of each. So if we have 0.1 mole of sodium, then how many moles of its oxide will produce? Hmm? 0.2. And if we calculate its mass, so what we have to do, we have to multiply this number of moles with its molar mass. So let's find out the molar mass of Na2O. It's 23 plus 23 plus 16. So total mass of Na2O.
62.
Mm, 62 grams and 0.1 mole of each sodium, they are saying. So if you multiply this 62 with the 0.2 grams. So can you please hold for a second? Fine, do it. I'll be back.
Okay.
Okay, so actually, wait, we are taking the ratio 1:2, so that should be opposite of that. So 2:1. So if we have 0.1, so how many moles of Na2O will produce? So X is 0.1 divided by 2.
2.
Hmm. So 0
0.05.
0.105. So this, yes. And let's multiply it with 62. So how many grams? 62 into 0. 3.1. Yes. So similarly, let's find out with the magnesium. So magnesium, when burns in oxygen, it gives us magnesium oxide, right? So let's say it's half O2. So it's 1:1. So 0.1 will produce 0.1 moles of magnesium oxide, and its molar mass, that is 24.3 for magnesium plus 16. So the molar mass is 40.3, right? So if we multiply it with its moles, 0.1, so the answer is 4.03. Means this is correct. Okay, now let's see phosphorus. Okay, so when phosphorus reacts with oxygen, it gives its oxide P2O5. Hmm? Now,
Mm-hmm.
I can write it 2.5 and 2 here, right? to balance it. P2O5. So the ratio is 2 and 1. So if this one is 0.1, so just like sodium, so how many moles of
Well,
P2O5 will produce? 0 point?
0.05.
Okay. And if you multiply it with its molar mass, 0.05 multiplied by the molar mass of P2O5. So let's see, phosphorus is 31 plus 31 plus there are 5 oxygen atoms, so 16 times 5. So if we add it, the answer is 31, 100 and
142.
okay, 42. Wait,
Mm-hmm. And
let me check. Okay, 142. So if we multiply it with this, so what's the answer?
7.1.
7.1. Yes. So it means all of them. 1, 2, and 3. Clear?
Yes.
Okay, now let's see another question. Question number 20. Hmm. A mixture contains magnesium carbonate, okay, and barium carbonate. So BaCO3 only. A sample of the mixture is dissolved in nitric acid to produce a solution. As we know, it's an acid, so it will react with them and will produce their salts. Clear? So that will be present as barium nitrate aqueous, isn't it? And this will be present as magnesium nitrate, right? So we will have, and all the
Yeah.
nitrates are soluble. Clear? Okay, they are saying
Yes.
in this solution, how could this solution be processed into a magnesium compound and a separate barium compound? Hmm. So we have these two ions in it. They are saying add acid, filter of the solid barium chloride. Okay, when we react this solution with the hydrochloric acid, so what about barium chloride? We know the solubility principle. Hmm. So what's that? All chlorides are soluble except silver, mercury, and lead. So it means barium chloride is aqueous, soluble. So we cannot filter it off, isn't it? They are saying on adding HCl, it gives barium chloride, and that is insoluble, so we can filter it. So option A is incorrect because it is soluble. So on adding acid to it, filter off the solid magnesium chloride. So what about this? Magnesium chloride. As I told you, all chlorides are soluble except silver, mercury,
Mag-
and lead. So this is also soluble, aqueous, so we cannot filter it off. They are saying add sulfuric acid. Yes, if we add sulfuric acid to these solutions, so what happens? The sulfate of an acid will combine and it gives barium sulfate, which is insoluble. While magnesium, when combined with the sulfate ion, it will give us magnesium sulfate, which is soluble, aqueous. So they are saying add sulfuric acid, filter off the solid barium sulfate. Yes, we can filter it off because it is insoluble, right? Which will
Yes.
form on addition. Okay, add sulfuric acid, filter off magnesium sulfate. So it is incorrect because it is soluble. Clear? So option C
Yeah.
is correct. Now let's see another question. Question number 21. Now, in this question, they are saying sample of magnesium nitrate here is heated. So first of all, we should know this reaction, magnesium nitrate. When it is heated, it is decomposed into its oxide, metal oxide, along with the NO2 gas and O2 gas, right? So these are the products which will form in this case. Now, they are saying when these gases, the solid will remain there, right? And these gases will pass through the water. And here we get a gas. So which gas is soluble? So this one is, I know, acidic gas, right? So that will react with water and gives us an acid. They're saying the pH of the solution in the trough is measured. So due to NO2, we know that solution here will be an acidic. So the pH should be less than 2, less than 7, sorry. So A is gone and C is gone, right? Now
Yes.
we are left with these two, C, B, and D. And they are saying the gas collected here, which is O2, we know, it says extinguished splint test. Extinguished or relights. So O2 relights the glowing splint. So option B is correct,
B.
right?
Yes.
Got it? Okay, now
Mm-hmm.
let's see another question. Hmm. In question number 22, the results of tests performed on a white crystalline solid X are given in the table. So they are saying reagents and conditions and observations. So X is gently heated and X sublimes. So if we remember, there is one compound which we discussed in the sublimation, ammonium chloride. So here in our options, they have given us aluminium, aluminium, ammonium, and ammonium. Okay. So one hint that ammonium chloride sublimes, right? And what about this aluminium chloride? So as we discussed about the structure of aluminium chloride, it's a simple molecular structure and it exists as a dimer, isn't it? So Al2Cl6. So this couldn't be this A or B. So it could be C or D. Now, what next they are saying? This X is shaken with H2O, okay, a colorless solution Y forms. So that is the aqueous solution of an X. And when Y is warmed with sodium hydroxide, so if we have these two ions, aluminium ion and ammonium ion, if you remember their identification. So when we add few drops of sodium hydroxide, so what happens to the aluminium ion? It gives us white precipitates, isn't it? Which dissolve in excess. But if we have ammonium ion in a solution and on addition of sodium hydroxide, so what happens? We get ammonia gas, which is given off. So they are saying Y is warmed with sodium hydroxide and a gas is given off. So now second hint is available about ammonium ion. The first with sublimation, and now we got the confirmation that it is ammonium ion which is present in a compound X. And Y is aqueous solution of this compound X. So here it's ammonia gas which will be given out. So if aluminium would be there, it will give us white precipitate. Now next, this could be bromide or chloride. So they are saying silver nitrate is added to the Y, and we know on addition of this silver ion, if we have chloride ion in the solution, it will give us silver chloride solid, which is a white precipitate, right? And if
Yes.
bromide is there, then
Cream
yes, it gives us
precipitate.
silver bromide cream precipitate. So let's see what they have saying. So added to this Y and a white precipitate is formed. Yes, it's a white precipitate. So chloride is indicated, and when we dissolve it with the ammonia, so this is soluble in excess ammonia. Hmm? And remember, bromides, they are partially soluble. Hmm? And if there is a silver iodide, so which gives yellow precipitate, that is insoluble in excess of ammonia, right? So they are saying a colorless solution forms. That's the confirmatory test of this chloride. So which option? D is correct, right? Now, is it
Yes.
clear about these ions, identification of ions? And now let's move on to next question. Here, question number 23. They are saying silicon is heated in excess of chlorine producing compound J. So which compound it forms when silicon is heated in excess of chlorine? It gives us SiCl4. And we have discussed their properties. Which type of compound SiCl4 is actually? It's a simple molecular compound, right?
Yes.
Okay. They are saying an excess of water is added to the sample of J. So we discussed in period 3 elements, their chlorides, silicon tetrachloride or silicon chloride, when it reacts with water, it gives us SiO2, a white precipitate, a solid. And along with this, we get HCl gas, fumes of HCl gas. So now what they are asking about J. Structure of J, which type of structure it has? Giant molecular or simple? No, it's simple molecular. And is HCl produced? So yes, I have discussed already. It will produce HCl. So option D. To solve these type of questions, we have to remind the properties of these group 7 halides or sorry chlorides and oxides, which is in our periodicity chapter. Okay, should we move on to the next? Yes. Question number 24. They are saying in a catalytic converter, 5.6 gram of carbon monoxide reacts with an excess of nitrogen monoxide. So what is the role of a catalytic converter? Actually, it convert the harmful gases into less harmful gases, right? So, what happens? This carbon monoxide and nitrogen monoxide, they are converted into the less harmful gases. So, carbon monoxide converted into carbon dioxide, and NO is converted into N2. So we can balance this equation in either by placing 2 here and the nitrogens are 2 there. So 2 here and 2 here. Or we can balance it the half of it, isn't it? Just place 1
Yeah.
by 2 here. So the equation can be balanced in both ways. Now what they are saying, 5.6 gram of carbon monoxide reacted with nitrogen. So this is in excess. So we are not concerned with this. So carbon monoxide is our limiting reactant. So 5.6 grams. So how many moles of this, or we can simply calculate carbon monoxide, its mass according to the equation 12 plus 16, 28 grams. That is producing 44 grams of carbon dioxide according to the equation 1 mole of carbon dioxide. So if we have 5.6 gram of carbon monoxide, so how many grams of carbon dioxide will be produced? Cross multiply. Hmm.
8.
8.8 grams, right? So option A is not correct because they are saying 2.4 gram of carbon, so no carbon in our products. So 8.8 gram of CO2 and 8.8 gram. So either C or D. So now let's find out the mass of nitrogen. So how many grams of nitrogen are half N2 means half of 28. That is 14 grams here. So if we look at the ratio, so 28 grams of CO is producing 14 grams of N2. So 5.6 grams will produce how many grams? It's, sorry,
Sir, why
2.8?
is it not?
Yes,
I have a question. Why is it not NO2 in the products?
because it's a catalytic converter. So the role of catalytic converter is to convert harmful gases into less harmful gases. Or you can say which are not the pollutants. So nitrogen and carbon dioxide, they are already present in our atmosphere. So if it is NO, then it is again harmful gas, isn't it?
Okay.
And also from our calculations, we can see there isn't any carbon on the product side. So this, both of them are gone in the options, right? And now
Yes.
by doing our calculation, what answer we get? 1.4 or 2.4?
2.8
2.8.
D.
2.8 grams.
Yeah.
Yes. So option D is correct. Clear?
Yes.
Now let's see next question. Question number 25. Which reaction mixture produces an acidic gas? Okay. Aqueous ammonium nitrate and calcium oxide. So what's the nature of this calcium oxide? It's basic in nature, metal oxide, right? Is it clear? So when it reacts with
Yeah.
ammonium nitrate, remember ammonium ion, when it reacts with the base, so what happens? It gives ammonia gas, identification of ammonia. So here, ammonia is basic in nature. They are saying acidic gas. That means option A is not correct. What about option B? Calcium and aqueous hydrochloric acid. Okay, when metal reacts with hydrochloric acid, it will give us calcium chloride, salt, and H2 gas. So it's not acidic. So option B is gone. Now, potassium chloride, when reacts with sulfuric acid, so we have discussed this reaction in the production of halogen acids in organic part. So it will give us potassium sulfate and HCl gas. So which is acidic gas? Yes. So it could be this. Let's see this one. Sodium oxide, when treated with water, it gives us an alkali. Because we know metal oxides, they are alkaline in nature, group 1 metal. So no gas will produce here, right? So option C is correct.
C.
Now let's see another question, number 26. Hmm. Here they are saying ethanol can be used to make propane nitrile. This is propane nitrile with C triple bond N. And it is in two steps, step 1 and step 2. What happens? What we are observing here, alcohol is converted into halogenoalkane. So bromoethane, ethanol. So if we recall the reactions of these alcohols, so remember this reaction if we have an alcohol like this, partial negative and partial positive, and we treat them with the halogen acids like HCl or HBr. So what actually Br do in that reaction? So this bromide attacks on partial positive carbon and this OH, that is the leaving group, and we get halogenoalkane, right? Along with this hydroxide ions. So which type of reaction it is actually? So one nucleophile is substituting another nucleophile. So it's a nucleophilic substitution reaction. Yes, it's either C or D. It's not a free radical substitution reaction, right?
Yes.
And next is also the reaction of halogenoalkane. We also know that this cyanidine, when we treat it with halogenoalkane, so what is the role of this cyanide group? That it also attacks on partial positive carbon. And we get alkane nitriles, right? And Br
Yes.
negative. So which type of reaction? Again, it is nucleophilic
Nuclear
substitution reaction. So both
substitution.
the reactions are nucleophilic substitution. Clear? So option
Yes.
C. Now let's see another one. They are saying lithium aluminum hydride to form two optical isomers. So lithium aluminum hydride is a reducing agent, right?